Hello and welcome to this first video in a new video series on Matlab. Since it is the first video, I just give a short introduction and give you a brief overview on Matlab. If you like this video, give me a like. If you have special wishes on topics on Matlab, write a comment, and certainly it's a good idea to subscribe the whole channel. So here is the content. I start with the application areas of Matlab. Then I discuss a little bit numerical versus symbolic calculations. Matlab uses numerical calculations. I introduce the main window. I show you how to use Matlab's help, which is very powerful. And at the end, finally, I give you some useful commands. Okay, let's start with MathWorks description. By the way, MathWorks is the company that develops Matlab, and they write that Matlab is a high-level language and interactive environment for numerical computations. That's what I already told you, visualizations, and programming. You can apply Matlab to analyze data, develop algorithms to solve problems, certainly, create models and applications. And that's the reason why there is a wide range of applications, of possible applications. So this includes signal processing and communications, image and video processing, control systems, tests and measurements, computational finance, computational biology, and certainly also physics and especially also quantum mechanics. One remark regarding the name and its origin. Typically students think that mat means math, like mathematics. That's not true. Mat stands for matrix and lab for laboratory. And the reason is that Matlab is especially very fast if you use matrices and do your calculations with matrices. Okay, some words on numerical calculations. What does this mean? Matlab uses numerical algorithms to solve problems, and these algorithms provide just approximate solutions. So you have the analytical problem, you typically discretize it, and then you obtain an approximate solution at these discretization points. On the other hand, you have so-called symbolic calculations. For example, computer algebra systems like Maple use symbolic calculations. And here you apply methods and you obtain at the end an exact analytical solution. So not an approximate solution, here you obtain the exact solution. That sounds better, but certainly the range of application is limited here, because think of very complicated problems where you can't find closed formulas. There, symbolic calculations fail. Okay, let's look at a short example. We want to solve a simple initial value problem. Here we have the ODE, the first derivative of n is 0.1 times n of t. N of t is maybe a bacteria population or something. And we have an initial value that is at time 0. We have maybe 50 bacteria. And now we want to solve this with Matlab. First, we have to write a function where we include our ODE. That's done in line 3. And then we call the function ODE45, which is a Matlab's typical function to solve initial value problems. And the input arguments in the round bracket, you first have to include your function, which contains the ODE. Then you give the range from 0 to 30 time units. That's the range where you calculate the solution. And the initial value at the last position, that's a 50. And what do you get back? You get two vectors, a time vector t and a solution vector y. And if you look at the time vector, then you see that you only obtain the solution in certain time at certain time points. And that's because you discretize the time. It's not continuously. And then you can take these two vectors and plot the solution, and you obtain an exponential function. Now let's look at Maple, for example. You also have to implement the ODE and the initial conditions in the first two lines, and then you apply dsolve. And what do you get? You get the exact analytical solution. That's a function. You get y of t is 50 times e to the 1/10 times t. That's the exact analytical solution, and not just a solution at discrete points, which is approximate. And that's the important difference between numerical and symbolic calculations. Okay, I think it's time to switch to Matlab. This is a 2020 version. Maybe your layout looks a little bit different. And if you destroyed your layout or you want the standard layout, you just click here in the menu layout and can use the default, then it's restored. Yeah, that's the typical layout that I use here. So what do you see? In the middle is a command window. Yeah, you can write commands. For example, 1 plus 3, it's 4, like a big pocket calculator. On the left hand side, you see the current folder and the files which are contained in this folder. Here are a lot of M files. You can maybe open these files here in the editor. We don't need it, so that's why I close it. On the right hand side you have the workspace, and you see that here is already a variable contained in the workspace. It's the answer of the calculation 1 plus 3. So if I now implement a variable a and I assign the value 5, then you observe that in the workspace you now have the variable a. You can also implement a variable b, maybe b is 2, and then I can calculate a plus b and obtain 7. You see everything is here in the workspace. Some useful hint is if you want to change now the a, you just type a, and if you use the arrow keys up and down, you can move in your command history. You see highlighted all the commands that start with an A. Here is A equals 5. Maybe I want A equals 3, and now it's changed. Another useful thing is you see if I write A equals 3, then you always get an output here in the command window. If you write A equals 3 with a semicolon at the back, then the output is omitted. Okay, now the command window is full with lines. With CLC, you can clear the command window. If you want to clear the workspace, you use the command clear. Clear would clear all variables. If I write clear A, it just clears the variable A. Now I use clear, and you see the complete workspace is cleared. Some further remarks. If you write pi, you obtain the number pi, 3.1416, but only with 4 digits. So if you use the command format long, then you change the display format, and if I once again write pi, you now observe more digits. That's just the display. Internal, Matlab always uses more digit, although it just shows 4 digits in the first example. Okay, if you forgot maybe what a command does, you don't know what does the command for, then you just write help, format, and then you get help text. And at the beginning you see set output formats, and here you see the options. Short, that's the default, long is what I changed, and so on. And at the end you also see documentation for format. If you go onto this, then the Matlab documentation opens, and the Matlab documentation is really nice. Now here you once again see the syntax, some examples. They also use pi. You can go through this. A lot of examples. Here you see the input arguments, the options, and it's always a good idea to look into the Matlab documentation. By the way, if you ask Google, then the first answer of Google is always Matlab's documentation. Okay, now I want to calculate the sine of an angle. I just write sine, round brackets, and then I input the angle as argument. By the way, the angle is in radians. And if you write sine 0, you get 0. Sine of pi should also be 0, but now you obtain this number. It's scientific notation. That means 1.22 times 10 to the minus 16. So it's a very small number. It's not exact 0, but it's very small. And that's once again the reason is that Matlab just calculates approximatively the sine. So in the real world, you would obtain a 0, but Matlab gives you a very short number. You always have to keep this in mind. Okay, the last thing for this video I want to show is how to implement complex numbers. If you use sqrt, it's a square root of 2, then you obtain 1.41, that's okay. And if you calculate the square root maybe of -1, then you obtain this number. It's 0 plus 1 times I. And you see it's a complex number. And that's exactly the way how to implement complex numbers. Let's call the complex number z, and the real part is maybe 2 plus 3 times I. 3 is the imaginary part. And then you obtain the complex number 2 plus 3 times I. Another complex number -1 minus 4i. And if you then do z plus w, you obtain the sum of the both complex numbers. You can calculate the real part of z by real, and you can calculate the imaginary part by imag of z. One remark here, be careful. If you use for loops, sometimes or often you use I as index. If you work with complex numbers, it's not a good idea to use the letter I as index, because it's reserved for the complex numbers. This is a very hard to find mistake in your source code if you use running index I and you work also with complex numbers.